So we're continuing or finishing 7.5, which is variations. We have to finish the joint variation, and we will start and finish 9.1. So I think on Sunday you will have to finish 7.5 and 9.1 also. Yeah. All right. So let's start. Let's open the page. Oh, share desktop. Okay. So let's see. Where's my note? And 7.5. Okay. So next one. So we talked about what type of variation? Direct, and inverse. Okay, and you know why something is called direct and something is called inverse? Why? Why is it called direct variation? Okay, so it's direct because when x increases, y also increases. And inverse because when x increases, y goes the other way around. Yes. That's good. Okay. So now joint variation, how do I label it? Is it B1, B2, B3? Let me just check. B2, yes. So B3. B3. This is called joint variation. So for joint variation, there is no specific formula. The formula depends on the context. Yeah, I am going to write there is no specific formula. It depends on the context. So, for example, if I say y varies jointly as x and z. So how do I write y varies jointly as x and z? Y is equal to kxz. So sometimes it says y varies directly as x and inversely as the square of z. How do we write it? Any idea? Yes, so y equals to k, so the k is always there. That's right. There you go. Make sense? So there is no specific formula. Yeah. Or you could say y varies directly as varies jointly as x and the square root of w. So if there is no mention of inverse, everything is on top. So how do you like this? How do you write this? Y is equal to what? K, remember the K. K what? X, X what? X over W squared. Why is it over? Okay, but does it say inverse or no? No, so it's upstairs. So it's not in the denominator. So how do I write square root of W? So just put here, yeah. So if there is no inverse, then we don't put anything as the denominator. Make sense? All right, good. So as I said, there is no specific formula. It depends on the context. Yeah. Let me me see where is this one. Okay. So this is joint variation. Maybe I should write it on a different page because this is long. Okay. So, oh, probably I could do it here. So, for example, the volume V of a given mass varies directly as the temperature T and inversely as the pressure P. Got it? If V, the volume, is 231 centimeter cubed, when T is 300 degrees Kelvin, and P is 20 pounds per centimeter square, what is the volume when P is 320 degrees K and P is 16 pounds and P is 16 pounds per centimeter square. All right. Okay. So when I read this, well, let me wait for you till you finish writing the problem. Yeah. So when I read this, I will do something. So V, what about the variation? That is directly as P and inversely as P. And then you have this number, this number, this number. Right? That's what is given. So what am I supposed to do here? What am I supposed to write? What's my formula? V equals K is always, right? K times P over P. So you can write it KP over P or KP over P. It doesn't matter as long as the K is on top. So you can write KP over P or KP over P. It doesn't matter. So you could put the K with the P together. Okay, either way. So KP over P. So K is on top. All right. So now, what else is given? V is 231 centimeter cube. T is 300 Kelvin. And P is 20 pounds per centimeter square. And you need to find what? Find the volume, so V, when P is equal to 320 Kelvin and P is 16 pounds per centimeter square. Are we okay so far? All right. So first of all, we need to find K, even though there's no mention you have to find K. And then box the equation of variation. So V is KP over P. All right, tell me how we could find K. Yes. So put all the numbers in. So substitute all the numbers. So what is the numbers here? 231 is equals to K times 300 divided by 20. So 231 is K times 15. 300 divided by 20 is 15. And divide both sides by 15. So what is K? 231 over 15. So this is my K. Okay? I don't, if I get the decimals, do I have fractions or not? Do I have decimals? So I want to keep the exact value, that's what I mean. Yeah. I don't want to truncate any decimals. Now, why don't I want to round? Because this is in the middle of calculations. Yeah. At the end, you can round, but this is the middle, so we usually don't round. Okay. So what next? We have to write the equation. Okay. What's my equation? V is equal to 231p divided by 15p. So this is fine. This is 231 over 15. Or you can write 231p and the 15 goes with the p because they're both denominators. So this is my equation. Alright, almost done. Then we substitute. So we have V is 231 times 320 divided by 15 times 16. So what's my answer? Oh. All right. What is it? 231. Yeah, 320 divided by 16 is 20, right? 20 over 15 is 4 over 3. So 231 times 4/3. What's the answer? 308? Did you guys get 308 or no? Oh, 231 over 15, maybe you could reduce, can't you? What is 231 over 15? 15.4. You could just write 15.4 here instead of these. Or you could write the whole thing. It doesn't matter. So this is 15.4? Okay. Sorry. Yeah. You just use 15.4 C over P. But what I'm saying is you need to keep the exact format, the exact value. Yeah, do not round on the middle. So 15.4 times 320 divided by 16. So yeah, it's 308. Yeah. And what is the unit? Yeah, so the volume is 308 centimeter. Centimeter what? Cube. Yes, volume is cube. Yeah. Okay. Is this doable? Yeah, not too hard, right? Not too hard. Do we need another example? Oh yeah? Okay. Okay. All right. So let's choose another one. All right. Okay. Let's talk about the atmospheric drag. Okay. So it's talking about wind resistance. Yeah. It's called the atmospheric drag. So, and you have to use calculator here because the numbers are in decimal. So, ready? Yep. Okay. Continue. So this is number 1. Let's do number 2. Okay. So number 2. So wind resistance or it is called atmospheric. So this is or. I should try. Or atmospheric drag. Okay. Tends to slow down moving objects. Moving objects. So anything, right? If you have a plane, this is like against the wind. Even if you have a car and you drive it fast, or even not fast, you have wind resistance. Yeah. Fast and Furious. Do you know the movie? I didn't watch, but I know what it's all about. And then the actor died, right? Yeah. He hit a car crash with a tree.
Oh, Aaron.
Yes, maybe because of the wind resistance. No, just kidding. Maybe because he drinks or he was under influence, right? DUI. Okay, well, I don't know. I have no opinion on that. Yeah. Okay. So, atmospheric drag, W. So, we use the symbol W here, probably for wind, varies jointly as an object's surface area A and velocity v. So if a car traveling at a speed of 40 miles per hour, at the speed of 40 miles per hour, so I'm just going to put mph, that's 40 miles per hour, with a surface area of 37.8 feet square, experiences a drag of 222 newtons. So N is newtons. How fast must a car with 51 feet square of surface area travel in order to experience a drag force of 430 newtons. Okay, well, this paragraph is pretty long. Feels like an English class, right? Okay. All right, but we could sort of bisect it, or dissect it like in biology. Yes. So I'm going to use my highlighter, or I could just circle the most important one. What are the variables that we have? W, A, velocity. I think you guys are still writing. Okay, I'll wait for you. What happens to W, A, and V? Varies jointly. What does it mean? Is anything going to be going to denominator? No. If nothing, no inverse is mentioned, nothing goes on the denominator. Right? And then I also have this 40 miles per hour. This is 37.8 and 222. So that's what is given. Yeah. All right. So now let's start. What is given? Formula. What's the formula? Yes. W is equal to KAV. So the K is always there, even though it's not mentioned. It's the constant of variation. And what else is given? 40 miles per hour. Which one is it? A, V, K, or W? V is 40 miles per hour. 37.8 feet square. Yes. 222 newtons. W. W is actually a force. Force is in newtons. Yeah. Wind, atmospheric drag is a force. Force is newtons. So what do you need to find? What is the question asking? How fast? So how fast is what? K, A, V, W, or what? V. Find V when what? A is 51 feet square and W is 430 meters. All right. So we find K first, as usual. Okay. W is equal to KAV. We know the W. What's my W? 222 is equal to K times 51 times 40. Is it? No, not 51. It is what? Yes. So good. At least one of us is awake, right? Good. I mean, you are awake. I'm asleep. That's what I meant. Because it didn't say, look at these. W varies generally as an object's area and velocity c. So no, there's no AV square or nothing. It doesn't say anything about the square. Yeah, so it's just whatever it is. 222 is equal to, what is it, 37.8? Oh, 1512? Okay. Then how do we solve for K? So let's see, do we have a lot of decimals or not? So 222, so divided by, oh, okay, then we should just leave the number as it is, right? You know, this is a lot of decimal, 0.146825397. So let's just leave it its value. Unless it is short, like 0.4, 0.45, 0.672, but this is the decimal is long. So we will leave it as it is. We will keep the value of K. Yeah, why? Because we do not round in the middle. We only round at the end. Yes? Oh yeah, that's right. See, I'm sleeping again. Yes, Johnny, thank you. So 111 over what? Sorry? 7 what? 76. Okay. Yes. Can we simplify it more? Oh yeah, divided by 3. Oh, still going. So what is 111 divided by 3? 37. 37? Okay. And then it's 252. Oh, okay. Can we make it smaller? No, right? I hope not. 37 is a prime, so your K is 37 over 252. Yes, it is better if you could simplify it. But if you don't, does it matter? Actually not. It doesn't matter to your answer. But sometimes in MathExcel, they ask you, what is the constant of variation? So if in MathExcel ask you what is the constant of variation, what would you answer? 37 over 252. Yeah. Yes. If still Still, you have to simplify your answer. Really?
Yeah, like you know, I guess only when it says simplify. The right answer
Oh, but it is if you simplify it. I thought if you don't simplify it, then they say that. Now, this is when you simplify this?
only when it says simplify it, you do it.
If not, then you don't? So in general, you have to actually simplify all of them. Yeah. Okay, well, anyway, this is what I said. Math Excel is stupid. That's what I always say, right? It doesn't know, like, I mean, we're human, we're smarter, right? Okay. Now, anyway, let's continue. It's a machine, so it can only read whatever people program them, so that's why. Okay. Now, so let's write down my equation. This is your constant of variation. What about the equation? Does Math Excel ask you equation also? Yeah, right? Equation of variation. So K, where's my K here? Oh, 37 over 252 times A times V. So this is the equation. And after we have the equation, then it's easy. Let's see, my W is 430. Is equal to 37 over 252A. Where is my A? 51 times V. Oh, V is the one that we're looking for. So 430 is equal to 37 times, oh, what is 37 times 51?
1887.
Yes. 1887 over 252. Is it a fraction? Yeah, I think so. 1887 over 252V. So how do I solve for V? Multiply by the reciprocal, which is 252 over 1887, right? All right, so that's how we got the V, and that now we could round. So 252 times 430 divided by 1887. So is the answer 57? Yes, 57.4. All right, now here we could round, not in the middle. Yeah, so how do I answer my question? Velocity is approximately 57.4 units. Yes, there you go. Finish. All right. Yay, nay, maybe so. Yay. Okay. All right. Now, let's talk about, I'm done with 7.5. So should we start 9.1? So we did chapter 8, right? Okay. So chapter 7 and then chapter 9, 9.1. Yay. Okay. Oh, this is math 115? Let me see. All right. That's math 125. Okay. So, inequalities. So chapter 9 is all about inequalities. So it's in one variable, and then it's in two variables. That's the last one. Let me see where it was. Okay, here. So let's do it. So I'm done, so I'm going to save this. File, save as. Save as. Okay, 7.5 formulas. Okay, all right, good. So this is the beginning up to the end. All right, cool. Now, let's do another section. So 9.1. Let me say this first. So we're done with 7.5, and we will start with 9.1, inequalities and domains. Yes? Okay, so 9.1 is inequalities and domains. Did you guys talk about the interval notation? Oh, we did? We reviewed it? Okay, good. So we don't have to review it, right? Right now. So let's just do the equality. So solve graph, and then state the solution in interval notation. Okay. And set builder. So let's do set builder also. So both set builder and interval notation. So number 1. 4m plus 7 is greater than or equal to 14 times n minus 3. And then number 2, 8x minus 3 times 3x plus 2 minus 5 is greater than or equal to 3 times x plus 4 minus 2x. Wow, so long. And then the next one, okay, let's do it in a different page. So what would you do here? Distribute? You were right. By the way, when do we change the sign? Yes. That's right. Okay. Now, where do you want to have your m? On the left or on the right? On the left? Okay. So, so this is a shortcut. So look at this. I need 14m on the left, right? And what is the sign here? Positive. When it moves across this equal sign or inequality to the other side, the signs will be negative. So opposite. So 4m minus 14m. So actually it's the same as, oh, I'm subtracting by 14m both sides. Yeah, it's just that I don't write the subtraction, but I will just bring the 14m to the other side. Remember to switch the sign, to use the opposite. Now, I need to bring 7 to the other side, so this is plus 7. What is it going to be on the other side? Yes. Yeah. So the signs are the opposite. So negative 10m is greater than or equal to negative 49. Okay, good. Then what? Divide both sides by negative 10. And I'm supposed to switch the sign. So m is less than or equal to 4.9. Or you could write 49 over 10. It actually doesn't matter. 4.9 or 49 over 10. Now we're going to graph on the number line. Alright. 4.9, open or close? Close. The arrow points to the left because it's less than. Now, do you see how I draw my arrow? It's all the way till the end of the number line. So I don't want you to draw something like this, right? I'd like you to draw the arrow all the way till the end of the number line. So not this. Don't stop in the middle. When we do 9.2, you'll know why. Yeah, so it has to go all the way till the end of the number line. All right. So how do I write my set builder solution? Yeah, so m, curly bracket, m such that, do you remember this? M is less than or equal to 4.9. And then you could say m is a real number, or you could write this, m is an element of real number, but this is optional. No, you don't. So should I write down what it means? So this e mean, this weird e mean is an element of. Greek letter, right? And then this R with double bar, this is a universal symbol for the set of real numbers. So everywhere uses this, the E and the R. Meaning they know, if I write E like this, they know it's an element of. Yeah, everybody knows. Do I have to put comma, M is a real number? No, you don't. So we have assumption it's a real number. So this part right here is optional. Let me just write down optional. All right. Now let's write down the interval notation. So interval notation starts with the smallest solution to the largest. Which solution is the smallest? Negative infinity. What solution is the largest? Okay, so negative infinity. And for infinity and negative infinity, what do I use? Yes. Comma, 4.9, bracket. Do you remember this or no? Yep. Okay. So I don't need to review. Why is it bracket? Why is it parentheses? No, we're good. Doable? Easy? All right. Now, number 2. Okay, so what do we do? Yes. So 8x minus 9x minus 6 minus 5 is greater than or equal to 3x plus 12 minus 2x. Okay. Now we're combining like terms on the left and on the right. So 8x minus x, negative x. Negative 6 minus 5, negative 11. This is x plus 12. Okay. Now, do you want your x to be on the left or on the right? Yeah. Left, okay. So I need this other x. So what happens? Move it, and then it becomes negative. Yeah. Now this negative 11 should be on the right. So when we move it, it becomes positive. Okay. Okay. Now negative x, negative 2x is greater than or equal to 23. And then divide by negative 2. So the signs switch. Reverse. Yes. Negative, right? Okay. And I think you know what to do here. What do we do? Graph it. Negative 11.5 is close, open, close, to the left. Yes. Why is it to the left? It's smaller, right? Smaller means negative 100 is smaller, negative 15 is smaller, so it's the ones on the left. Okay, so let's write this. My solution is x such that x is less than or equal to negative 11.5. I'm just going to close this, or I could put comma, x is an element of real number. So either way. Yes?
I don't know if it will help anybody, but the way I remember is that this way forward is the sign in the direction.
Yeah, this one. So look at this. This looks like the tip of an arrow. Yeah. So if the tip, so it's like this tip, right? But it's only valid when your variable is on the left. So make sure if you use that, the variable is on the left. Yeah. So I'm talking about not something like this. 2 is less than x. It's not going to be valid here, right? You have to put your variable on the left if x is less than is greater than 2. If 2 is less than x, how do I make the x on the left? Yes. So then you can use whatever Jose says as the tip of your arrow. Yes. Good. Thank you. So far so good? Okay. So the variable has to be on the left if you were to use the guideline on the tip of the arrow. And what is my my interval notation? Yes, negative 11.5. Why is it bracket? All right, good. All right, doable? Yeah. So I don't have to do too much like this, right? Okay, can we just do the applications problem then? It's interesting, the application's interesting. Yes? So this is okay? Okay, good. All right. Now, the application sort applications. He talks about salary. So I'm going to ask Jesus a lot of questions today, okay, because he's busy. All right, so library, let's see, chapter 9. All right, so let's see here. Oh, this is 9.2. So what homeworks do you on Sunday? 9. What about 7.5? Okay. Yes. Yes. So even though I don't put in the due dates, you know it is due, right? Okay. So I might put the due dates later on, but you know it's due. Yeah. Now it talks about wages. So the short application. Okay. So Tony can be paid in one of 2 ways. So he's a salesperson. Okay. Plan A, a salary of $4,000 a month, plus a commission. So he's a salesman of 8% of sales. Or plan B, a salary of $6,100 per month. Well, what is he selling? Plus commission of 5% of sales. All right. So which one should Tony choose, do you think? Depends on how much sales it is, right? Yeah. So the question is, for what amount should Tony select plan A? So that is the question. All right. But you guys get you can visualize what happens, right? Tony is making money, and he could be paid in 2 ways. So he needs to choose one. So he needs to figure out, if you were Tony, what would you do? So the question is, for what amount should Tony select plan A? When would he select plan A? When he makes more sales. That's right. Yes. When he's making more. Right? Okay, so now, first of all, I need my variables. What is my variables here? So what do you think? What will my X be? X is plan A. But we already know it's 8% and 5%. So what is X? The amount of what? The sales, yes. The amount of sales, you're right. So it all depends on the amount of sales, right? Okay, good. Actually, sales. X is sales. The amount of sales or just sales. Yeah. All right. Now, step 2, we skip. We don't do anything. Step 3, we will write the inequality. Okay. When do you think Tony would select plan A? If he's making more. So I could write something like this. I would select plan A if plan A is greater than plan B, because otherwise he would just select plan B, right? Actually, if I want to be correctly, very, very correct, 100% correct, so I will write the amount made in plan A is greater than the amount made in plan B. So you want me to write that down? The amount earned in plan A is greater than the amount earned in plan B. Does that make sense? Okay, or I could just write down plan A is greater than plan B. So what is plan A then? What is the amount earned in plan A? 4,000 plus 8% of sales. What is 8% of sales? 8%. Yes, 0.08x. Yeah, so you have to change the percent to decimal. And then greater than, how much does he make in plan B? 6,100 plus x. Yay, that's right. Yeah, can you solve it? Of course, right? Okay. I'll wait for you. So you could just leave the decimal there because we use calculator anyway, right? So this is 0.08x, and then, oh, this is 0.05, so minus 0.05x, and then you have 6,100. What do I do with my 4,000? When you bring to the other side, minus? Yes. Okay. So this is 0.03x is greater than 2,100. Divide by 0.03. Okay, what's that? Okay. Good. So when should he select plan A? No. More than $70,000 in what? In sales, yes. So Tony should select plan A when sales is greater than, what is the unit? Dollars, right? $70,000. Does that make sense? Easy? Should we do one more? Yeah. Okay. There is one in it talks about hospital bill in your math Excel. I'd like you to try it. Yeah, it's a little different. So number 2, yeah. And if you have questions, we could discuss about it on Monday. But I'd like you to try the problem involving the hospital bill in math Excel. So this is a wedding photography. So Eli will photograph. Oh, by the way, are you guys done with the other one? Yeah? A wedding for a flat fee of $900 or for an hourly rate of $120. For what length of time would the hourly rate be less expensive? This is easier than that one, than the previous one. All right, so how do we answer this? So can you visualize what happened? What does Eli do? He's a photographer, right? How much does he charge? Yes. If you want flat rate, he's going to charge you $900. Yes. So the question is, for what length of time would the hourly rate be less expensive? So what is X? Length of time. Right? Or duration of the photography. Yeah. Step 2. Well, there is no drawing, but we can take a picture and put it there. Right? Wedding picture, put it there. Now, step 3. What should I write? So hourly rate is, what is the sign? Greater than, less than, equal, or what? Less than, flat rate. Okay, good. So what's the hourly? 120. What's my inequality? 120 is less than 900? Is that how I should write it? 120 what? X. Yeah. Right? The length of time, the number of hours. Yeah. So 120x is less than 900, so divide both sides by 120. What is it, 7? 7.5. Yeah. So this is step 4 and you solve. So how do I answer this question? Hourly rate, this is step 5, right? Rate is less expensive if what? The length of time, yeah, is less than 7.5 hours. All right. Yes, doable? Okay, so this is 9.1. I am done with 9.1. That's it. That's it, yes. But I'd like you to review the interval notation, right? Make sure you know how to do the interval notation. Really know how to do interval notation. Yeah? All right. So I think I will finish 9.2, 9.3, 9.4, 9.5 this week. Next week, sorry. So when do you think you'll have a test? The following week?
Yeah.
Maybe Tuesday? Wednesday? Okay. All right. Tuesday or Wednesday next week, okay? Now, let me close this. Or are you still writing? I need to call your attendance. Yesterday I forgot also, right? Okay, guys. We're done with 9.1, inequalities and domain, and I will see you on Monday. Okay? All right. So.